utilize a bioreactor alwaysly for the mammalian cell, right? The second difference, whatever your fermenter are there, basically they are of a large size, whereas the bioreactor they are of a small size. That is second difference. The third difference, that growth rate, which is going to occur in a case of your fermenter for a few days to week, whereas in case of your mammalian cell, it is going to take us several weeks. What is the reason? What is the reason? Yes, the change, there is a difference in a growth rate, absolutely right. The next thing, that is maintenance of pH. Now it is very crucial point, people are not aware with this idea that why there is an attachment of this kind of a cylinder is there, that whenever you are going to maintain the pH in case of a fermenter, you are aware with the fact that at the top there is an attachment of a different kind of a bottles are there, and that bottles they contain usually acid as well as a bases, and they are going to move along with the help of a peristaltic pump, right? And as a result of that, depends on the requirement, acid or base is going to enter inside the reactor. In case of your bioreactor, over there you attach the CO2 cylinder. The CO2 cylinder is going to do, basically the maintenance of pH is going to be performed by the CO2 cylinder, and this particular CO2 cylinder is going to maintain a particular kind of buffering system. What kind of buffering system? Carbonate, bicarbonate buffer system, right? As a result of that, the pH is going to get maintained inside the bioreactor where you have added your animal cell or your mammalian cell. The next difference, that whatever your fermenter are there, they are basically going to work at the RPM of around 800 or sometime more than that particular. But mind over here, you can see, you are able to see over here that whatever your bioreactor is there, in that the RPM is available only 150 or less. Any specific reason? Can you answer me?
They lack silicone.
Exactly, right? Whatever the cell which are available inside the fermenter, they are basically a microbial cell, and they possess what? Cell wall. Over here, whatever the bioreactor is there, that contain a mammalian cell or the animal cell, and they possess cell wall? No, they do not possess cell wall, right? So as a result of that, they are going to become more sensitive, and that's why we require to maintain the RPM when you are going to work with the mammalian cell in the bioreactor, that is around 150 or less. Next difference, that is about the foaming. Basically, there are a number of times they are going to ask you a question that how you are going to maintain the foam, and the common answer available with your students that we are going to add the anti-foam agent, right? Now there are a number of times that there are several papers are there. I will show you that JNU papers, they have asked this question very commonly. That we'll discuss about that later on. Now whatever the anti-foaming agents are there, basically they are the oils, right? They are the oils, and what different kind of oils you are going to add. So as a result of that, the foaming is going to get inhibited. But in detail, they are going to ask you next question immediately, that how this oil is going to eliminate the presence of foam. What is the reason behind it? The answer to this question, that whenever you are going to add the oil into the media, whenever the foaming is occurring, this particular oil is going to decrease the viscosity. So if viscosity is not there, then there is no attachment of bubble. And if the bubble attachment is not going to occur, then there is no formation of a foaming is going to occur. Right? Then there is no formation of foaming is going to occur. Yes? Any doubt? Yes.
Sir, how it is?
Yes. I will try to explain you by the means of drawing what is happening actually. The meaning of foaming is what? As for example, this is your reactor. This is a reactor and you are working over here. Now whenever you are working in a reactor, at that time, due to the movement of your impeller, the foaming is going to occur. Now whenever the foaming is occurring, it is going to behave like this. You are able to look like this? Yes. The foaming. Now if you try to observe this foam very minutely, what are these foam? They are nothing but the aggregation of bubbles. Whenever these bubbles are going to get aggregate with each other, as a result of that, they lead to formation of foam. You have seen the child, that what child is doing, he is playing with that stick and he is trying to produce the balloon or the bubble into the air, right? The simple way. The same way is happening over here. Whenever you are going to add the oil, into this particular media, which is your antifoam agent in case of your fermenter, at that time this oil is going to bond to the boundary of your foam. Are you getting my point? Everybody?
Yes.
Are you getting my point?
Yes.
Whatever the oil is there, it is going to bind with the boundary of each of the bubble. And if the oil is bound with each of the bubble, you are aware with the nature of oil, so it will not allow to interact with each other. And if these two are not able to combine with each other, they are never going to produce a foam.
Yes.
They are never going to produce the foam. So this is how your oil is actually behaving, right? This is how it is going to behave and going to perform the activity. In the case of mammalian cell, this particular phenomena is not common. Why not common? Can you give me the answer?
Vigorously seeding नहीं होती.
I am talking about the mammalian cell bioreactor. In the case of bioreactor, yes, you are right with the answer. In the case of bioreactor, the foaming phenomena is not common. What is the reason? The reason is,
Low RPM.
yes, you are working at the 150 RPM, right? So the RPM is very less. RPM is very less, so there is a very less chance that your foaming is going to produce, right? So that the utilization of antifoam agent, that is not common in the case of your bioreactor. And last one, again most common one, whatever your fermenter is there, you can operate in both the situation, aerobic as well as anaerobic, whereas you can work with your mammalian cell always in a aerobic condition. So these are the major difference available between your bioreactor and fermenter. If we talk about the fermentation process in detail, basically your fermentation process is divided into two different stages. The first stage or the top stage, that is known as the upstream stage. The meaning of upstream stage over here, that you try to prepare for various conditions. As for example, you are trying to prepare the media, you are trying to prepare your autoclave, you are trying to prepare your bioreactor, you are trying to collect everything, you are selecting your microorganism, you are screening your microorganism, everything that come under the category of your upstream process. Once you have collected everything, now you are going to keep that things inside the reactor for a particular time, right? As for example, particular 24 hours time, 37 degree centigrade and 7 pH. So you have kept the things inside the reactor. Now once you have kept the things inside the reactor, the next stage, that is a collection. Now in the collection, what you are going to do? You are going to try to recover the process. So that particular process is known as a downstream process. So your entire fermentation technology is divided into two different stages, right? The first one, that is the upstream, that is known as the preparatory stage. The second one is downstream, that is known as a recovery, where you try to recover the product. Are you getting me? Now, the next most important part again, which is coming frequently for entrance examination, that is about the designing of a fermenter. And as you are able to see, there are different parts of fermenters are there, but it is impossible to discuss in detail about each and every part, right? But first of all, how we define the fermenter? Basically, the fermenter is defined as a large vessel which contains a sufficient size of nutrient media and which is necessary for the growth of organism, that basically known as a fermenter. Believe me, you have two questions very common all the time. One, what is fermentation? The second, what is fermenter? Try to understand what is fermenter. It is a large vessel which contains sufficient amount of nutrient media which is necessary for the growth of organism, that is known as a fermenter, right? Now you are able to see the image of fermenter over here. There are different parts are there. You are able to see different parts over here. It starts with impellers, parger, followed by baffles, load cell, inlet, pH meter, flow cell, streamline. Now again you check the previous year JNU or the IIC question paper. The major question has been asked on 2 or 3 concepts. One of the questions they have asked very commonly, that for thorough mixing of medium and the inoculum, part of fermenter is useful is?
Impeller.
For the thorough mixing of a medium and inoculum, the part of fermenter is useful is? Impeller, right? Impeller. That is a particular part. Now I would like to give you one particular tips over here, that when you are preparing this kind of a multiple choice question, how to prepare MCQ. As for example, you have 5 or 7 days left with the preparation of your exam. How to prepare them? As for example, you have this particular question is available in front of you. It was asked in a JNU examination. Excuse me. Now, you are aware with the fact that the answer is impeller, right? But how to prepare this particular question? You need to understand that, as for example, the shaft is written over here. What is the function of shaft? You need to understand. As for example, headspace is mentioned over here. What is the function of headspace? You need to understand that. You are not supposed to move further by taking only at the time of preparation on impeller. You are aware with the answer with the impeller, that is true. But if you are going to clear all the option, that is what is the function of shaft, what is the function of headspace, what is the function of sparger, that means in one particular question you have prepared 4 different answers. Are you following me? आप एक क्वेश्चन तैयार कर रहे हो, उसके साथ आपको 4 अलग-अलग आंसर मिल रहे हैं। आपको पता है कि इस क्वेश्चन का आंसर इंपेलर है, लेकिन आप डिटेल में जाएंगे और सोचेंगे कि हर एक ऑप्शन का फंक्शन क्या है, हेडस्पेस क्यों है फर्मेंटर के अंदर, स्पार्जर क्यों है फर्मेंटर के अंदर, राइट? तो आपको क्या पता चलेगा? You are able to understand आंसर of 4 different things, right? So in a way, at the time of attempting a one particular question, at the time of solving a one particular question, you have solved automatically. Clear? 4 different questions, right? It is not necessary all the time they are going to ask you the same question, right? But from this, they are going to ask you a question. Now next time they are going to ask you a question, then what is the function of sparger in a fermenter? So if you prepare by this way, immediately you are able to recall the thing that sparger is there for addition purpose. Are you getting my point? Right? Again, the most common questions which are coming from the part of fermenter, that is about the baffles. Baffles are there. Baffles are basically nothing but this kind of a metal strips are available. You are able to see the metal strips, right? And these baffles are there. In the next image, you are able to see that these baffles are available inside the bioreactor. What is the function of baffle? You can see the image over here. Basically, whenever we are applying the impeller, whenever the agitator is working, as a result of a continuous rotation into the media, the common situation is going to arise, there is a vortex. That is a vortex. Now, if the vortex is going to occur, what will happen? It will not allow appropriate mixing of a media. As a result of that, your organisms are not able to utilize a particular source which is available inside the media. So what you require? You require to inhibit formation of vortex. You require to inhibit the formation of vortex. As for example, I am throwing the pen from here to here. I am throwing the pen from here to here. If I put my hand in between, then what will happen? Then what will happen? It is going to bind with this, right? It is going to come in contact with this, it is going to fall down over here. But if I am not going to put my hand, I am going to throw this pen from here to here, it is going to move. Like the same situation is happening in the case of your vortex, right? Whatever the baffles are there, they are basically a metal strip. Presence of a metal strip inhibit the formation of vortex. You are able to see these blue lines which is available over here. If, as for example, in the center there is no baffles are there, so you are able to see the media is continuously rotating, and as a result of that there is a formation of a vortex, right? But you can see at the borderline baffles are available. That is this is the actual scenario, right? This kind of a metal strips are available. Now, if these metal strips are there, and if the media is going to rotate, so it is continuously going to come in contact with this particular metal strip. And if they are coming in contact with the metal strip, that means they are not able to complete the circle. If they are not able to complete the circle, then there is no formation of a vortex is going to occur. Are you getting my point? Right? Why there is a need of baffle? Baffles are going to inhibit the formation of a vortex. Now, another question which was asked in an examination, that is antifoam agent is. I have explained you already. What is the answer?
All of these.
What is the answer? Antifoam agent is silicon compound, corn oil, soybean oil. Answer is all of them. Majorly, what is going to happen? That 90% of a question you are aware with. I would like to give you another tip. When you are attempting the entrance examination, the 90% of a question, as for example, you are aware with that. You are confident in your mind that this 90% of a question that I am sure enough. 5% of a question are of that type that you are in a dilemma. What to do with this kind of a question, whether to attempt or not. Because you are in a dilemma. If I am going to attempt this kind of a question, there may be a chance that I am going to lose the mark. Right? So what to do with this kind of question? There are certain kind of hidden tricks, hidden tips are available with these MCQs, that whenever in any kind of a question you are finding this kind of a option all of above. Whenever in any kind of a question you are finding this kind of an option as a all of above, 95% case, in 95% case, this answer is always right. Right? This is a just statistical observation. Right? What is happening? 90% questions you are aware with that, 5% of a question as you are still in dilemma whether to attempt or not. You just go for those 5% of a question, try to identify these kind of options are available or not. If you are not sure, then and you are going to attempt this particular kind of option and you are going to click on answer D, that is all of above, in 95% of a case, you are going to get 100% mark in those kind of. These are the kind of a hidden tips, right? Another very important component, that is people are used to ask a number of people have asked a question from this particular thing in the